So today you're going to hear a talk about anti-phishing algorithms in UI from Jason Hong. He's a professor at CMU, and along with working on anti-phishing, he works on mobile computing, mashups, and he really likes the color green. Thank you.
Thanks, Pedro. Okay, so once again, my name is Jason Hong. I'm an assistant professor in human-computer interaction, which is part of the School of Computer Science at Carnegie Mellon University. And today what I'm going to talk about are some of our current work in user interfaces and algorithms for fighting off phishing attacks. Now, I'm sure everyone in this room, and probably their parents and friends too, have received emails that are like this. Please update your email account. Click on this link to do that. If you happen to click on the link, you get sent to a web page that looks like this. And if you continue to do what the email asks you to do, you'd fill in your account name, you hit the sign in securely, and then it would say, hey, everything's okay, don't worry about it. And if you actually did this, it turns out you would actually be a victim of identity theft. And this entire process is known as phishing. Okay? So this is where criminals are actually going out and trying to steal your identity and then steal your bank accounts or whatnot. Okay, so here are some fast facts on phishing. So I want to make sure that you take this with a grain of salt, because finding accurate statistics on phishing is actually quite difficult. We've been trying to talk to the banks, we've been talking to the FBI and Secret Service, and it's very hard to find any kinds of reliable statistics on this, but here are some of the ones that I've seen in the media. So roughly speaking, about 3.5 million people have fallen for phishing attacks. Okay, so that's a non-trivial number by any kind of metric. It's estimated to cost about $1 to $2 billion a year, and this is rapidly growing. The derivative is very, very high. Okay, so the $1 to $2 billion is in terms of fraud, in terms of lost revenues, and also in terms of emptied bank accounts. There are about 9,255 unique phishing sites reported in June 2006 alone. Okay, so that's just one single month. And I've also heard many reports from newspapers and media that it's actually easier and safer to do a phishing attack than to rob a bank. Okay, so I'm definitely not encouraging any of you guys to do this. But okay, if you think about just the sheer numbers, if you send out, say, 1 million of these emails, you only need about 3 or 4 people to fall for it. And if you get about 5,000 per person, that's about $20,000 right there. And again, much safer than robbing a bank. Okay, so what we're doing over at CMU is that we're trying to figure out how to help people make better trust decisions. So the entire project that we have right here is called Supporting Trust Decisions, and we're focusing specifically on anti-phishing right now. We have a large multidisciplinary team at CMU. We're right now supported by the National Science Foundation, the Army Research Office, and by Carnegie Mellon's a group called Scilab. This is actually our computer security consortium. We have 6 different faculty, 5 PhD students, undergraduates, and staff, and we all from very different backgrounds. So I'll just go quickly through who the different faculty are. This is Alessandro Acquisti. He's in the School of Public Policy. He's an economist by training. This is Lori Craner. She is probably best known for having developed P3P, the privacy policies. This is Sven Dietrich. He's part of CERT, the Computer Emergency Response Team. This is Julie Downs. She's a social psychologist by training and is part of the social decision sciences. This good-looking guy is me. And this is Norman Sade. He's an expert in commerce as well as machine learning. Okay, so what we're doing is we're trying to take a multi-pronged approach to this anti-phishing. We're doing this both from the human side and from the computer side. So with respect to the human side, we're trying to do, we've been doing a lot of these interviews trying to understand decision making. What are the cues that people look at, and how do they make their decisions when they decide to trust or not trust an email and a website? We've also been developing something called embedded training, and I'll talk a little bit more about this in a second, but can we actually train people not to fall for phishing attacks? So this is the main question we're trying to ask here. And finally, we've also been developing an anti-phishing game. So try to make it more fun, try to, again, surreptitiously train people to not fall for these phishing attacks in a way that's sort of fun. On the computational side, we've developed an email anti-phishing filter that's actually quite good. It's around 98% accurate in terms of detecting phishing emails. The reason it's grayed out here is that I'm not going to be discussing it today in terms of time. We've also developed an automated test bed for evaluating anti-phishing toolbars. So it turns out there's probably about 90 anti-phishing toolbars you can install into your web browser today. And what we've been trying to do is trying to understand, well, are these actually effective or not? And if so, what kinds of strategies are effective? Lastly, I'll be talking about an anti-phishing toolbar that we've developed, and it actually is very good. It's about 95% accurate or so in terms of detecting phishing websites. And the best part, of course, is that it's a very trivial algorithm and also uses the Google search engine to do this. And by the way, it also outperforms the current Google anti-phishing algorithm too. So we also have an underlying philosophy here, which is, okay, let's try to automate this where possible. So you can think of this like spam filters. You don't want to deal with spam manually yourself, so you would have a filter there that automatically checks it for you and gets rid of it for you. Okay, so it's the same thing here. We want to try to use automated algorithms as much as possible to get rid of phishing attacks and protect people from it. But we also want to try to support people to make better decisions where necessary. So again, have better user interfaces, better training, and so on to try to protect people. So I'm going to talk about the human side of things first, and I'll be taking a quick overview of our results in terms of interviews that we've done. Okay, so what do people actually know about phishing? So what we did is we interviewed 40 internet users, included 35 non-experts. So these are people who were had passed 2 different questions. One was, have you ever fixed someone else's computer before? Okay, so if they answered no to that one, that was a positive sign that they probably were not expert. And have you ever created a web page before? We did a mental models interview, and we also had them be part of an email role-playing situation. So the mental models thing means we're just trying to understand, we asked them to think aloud, and we're trying to understand what are their thought processes as they're looking at the emails, what are the cues that they're looking at, and what do they think is important and not important. So for the role playing, we had them go through about 20 emails or so, and the emails were in the context of you are Pat Jones, you're a member of this company called Cognix Inc., and you're trying to just clear out your email inbox. And so we asked people to go through the email inbox and respond to it as if they were this person. And sporadically spread throughout some of these were a few phishing emails. And then we recorded the interviews and also coded them up. This work is actually available. You can download this. Here's the paper reference right here. Or you can just ask me afterwards, and I'll get you the reference. OK, so the quick overview of the results. Only about half of the people actually knew the meaning of the term phishing. So typically, you would get comments like this. Well, it probably has something to do with the band fish, I take it. OK. So the awareness of just the specific term is actually quite low. There's actually also very minimal knowledge of the lock icon itself. So a very prototypical quote here is, I think that it means secured. It symbolizes some kind of security somehow. So 85% of the participants were aware of the lock icon. However, only 40% of those knew that it was supposed to be in the browser Chrome. Okay, so this is actually an important result because some of the newest phishing attacks use a picture-in-picture attack where you have just an image and you have the image of your browser inside of it. And this actually confuses a lot of people. So this is actually a fairly effective attack that's going on right now. Only 35% had noticed HTTPS, so the S part for secure socket layer, and most of those people didn't really know what it meant either. Okay, so again, probably the main thing you can take from this slide is general awareness is quite low of the lock icon. People also paid little attention to the URLs. Only 55% of the people said that they had ever noticed something strange with respect to URLs, and most of them did not consider them to be suspicious at all. Okay, so this is actually a very important thing too, because the URL is actually one of the few things that you can use to identify or potentially identify phishing websites. Okay, this is probably one of the most obvious signs that it's a phishing website, and if most people aren't recognizing it as a signal, then this is probably pretty bad. People did have some knowledge of scams. Roughly 55% of our participants reported being cautious when email asks for sensitive financial information. But on the flip side of things, very few people reported being suspicious of email asking for passwords. So there's sort of this general notion that people know that their financial information is important, but they don't quite realize that their passwords are important. So this is sort of an interesting finding here. Lastly, knowledge of financial phish reduced the likelihood of falling for these scams, but this knowledge did not transfer to other kinds of scams. So to give you an example of what happened in our interviews, in one participant, they saw a phishing email that was in our study, and they said, oh, this is probably a scam. And so they decided to just delete it and go on to the next email. And the next email was an Amazon email asking for them to update their account. And they said, oh, OK, well, Amazon's asking me to update my account. They already have this information. I'll go ahead and do it. Right. And this also turned out to be a phishing scam as well. So it was really interesting because they knew the defense for a financial scam, but they didn't realize that it should be transferred over to a different kind of scam. Okay? So generally speaking, probably the main thing to take out of this is that people's knowledge of these kinds of scams are very highly specific and not very robust. People also have very naive evaluation strategies too. So here are the 3 most frequent strategies that people did in terms of identifying phish in our interviews. First, does this email appear to be for me? Okay, so if you happen to have someone's name, specifically their name inside of it, they'd be more likely to fall for it. It's normal to hear from companies that you do business with. Okay, so if you already have a pre-existing relationship with a company, then people would say, okay, well, you know, I've already seen something from them before. I'll probably be able to expect something from them again. And then also the reputation of the company itself. So here's a prototypical quote that describes some of these. I will probably give them the information that they asked for. And I would assume that I had already given them that information at some point, so I'll feel comfortable giving it to them again. Okay, so there's some other findings we have inside of the paper, but let me just give you the quick summary of the rest of them. Web security pop-ups are very confusing. They're also confusing to me too, and I have a PhD in this area, so it's probably not a good sign. Yeah, like the certificate has expired. I don't actually know what that means. All right, so maybe we can even do a quick survey here. Does anybody here actually bother checking the security certificates of whenever they see those in their browsers? Okay, so yes, probably 6 people who I'm guessing would be computer security PhDs. Also, most people don't know what encryption means. Okay, so we have, so if you're using that kind of terminology inside of your system, it turns out most people just didn't understand what it meant and what the implications were. So the quick upshot of all of this, these studies and these interviews we did, first one is people are generally not good at identifying scams they haven't specifically seen before. So again, people's knowledge of these scams is very, very fragile. They're not very robust at the strategies. People don't use good strategies to protect themselves. Okay. Okay, so are there any quick questions on this before going to the next part? Yes?
You said people don't know what the term means, but do they know like what sort of means?
Okay, so the question is, do people don't know the specific meaning of encryption, but do they generally know what it means? The answer is also no. It's, people talked about I'm entering a crypt and going into circles or something like that. I mean, they just try to make up terms and meanings for it, but generally speaking, they just didn't even know what it meant. Yes?
I was a little curious at what information they had been given prior to the role playing. Like, did they know this was about security, or was it just about email, or maybe a user interface that we thought was something like that?
Okay, so the question was, how much information do we give beforehand? Did they know that was a security study? So the answer is actually no, they didn't know it was a security study. We said that this was a study on how people react to email. And the reason for this is the priming effect, because if they had known that it was a security study, then people would be probably more likely to act differently than they normally would. And of course, you know, if a criminal sends out a phishing email, they're not going to tell you, hey, this happens to be a scam. So of course, there's also a lot of ethics with respect to this too. So as you might know, a lot of universities we had to deal with institutional review boards to make sure that we're treating our participants ethically and that we can only use deception if this is the only way that we can get information. And we have to make sure that we have certain restrictions, that we treat the information correctly and so on. So we did follow all of that as well too. Yes?
So I've done some vaguely similar studies, and one of the things I learned was when the phishing was looking for a credit card, people were suspicious, but they basically said, not my problem, it's the credit card companies. I'll just, you know, if somebody uses it, just tell them that. And they were just, they couldn't get bothered enough to stop their shopping to deal with credit card phishing because they saw it as somebody else's problem. Did you see anything like that?
Okay, so the question, if I can paraphrase, is people felt that if the email was asking for a credit card, that they felt it was more the credit card company's responsibility rather than their responsibility, and probably partly because in the US you have a $50 liability maximum. We actually didn't see much of that specifically inside of our interviews. So I can't comment really one way or another on that one. Okay, so let's go on to the next part. So the next question is, can we actually train people not to fall for phishing attacks? So this is sort of an interesting question because if you go to a lot of security conferences, the general consensus is no. You know, people are generally naive, people don't really know what they're doing, and this is not really a feasible solution. Okay, so that's sort of the conventional wisdom on this. And we actually came up with interesting results, which is pretty much the opposite, that yes, you can actually train people. Yes, you can train Johnny not to fall for fish. So we did a laboratory study of 28 non-expert computer users, again, using the same kinds of questions that we used before to filter people to make sure that they weren't experts. We had 2 different conditions, and we asked both people in both conditions to evaluate 20 different websites. In the control group, they first evaluated 10 websites, and then we asked them just to take a break for 15 minutes. They could just check, you know, they could check their actual email, they could play solitaire, or do whatever they wanted for 15 minutes, and then go and continue and evaluate the final 10 websites. Okay, so again, 10 websites, take a break, 15 minutes, and then evaluate 10 more websites. In our experimental condition, we had them evaluate 10 websites. And then we had them, for 15 minutes, actually read some of the material out there to teach people not to fall for phishing websites, and then do 10 more websites. So for the material, we actually tried to look for what we consider the best material. So this included stuff from Microsoft, stuff from eBay, and stuff from the FTC, the Federal Trade Commission. Okay? And the material was generally talking about, here's some identifying factors, here's how you understand URLs, be wary of websites that ask for too much information, stuff like that. And trying to make sure that people can understand that phishing websites can actually look the same as actual websites. Okay, so roughly speaking, that's the kind of information that was in there. Our experimental group, so I actually won't show you the full results here. There's a lot of the statistical data and whatnot here, but the main thing to take from this is the experimental group actually performed significantly better in terms of identifying the fish after training. So they actually were less reliant on some of these naive strategies that I was talking about before, and some other ones that other people and we have also noticed too. So it turns out that people naively rely on how a website appears to judge whether it is trustworthy or not. So if, for example, that if you see a website that looks like it's professionally designed, then people would be more likely to fall for it as a phishing attack. But I'm sure everybody here knows that it's trivial just to copy of an actual website. So it's trivial to copy eBay's web pages, it's trivial to copy Gmail's web pages, and so on. So it turns out in our experimental condition that people were far less reliant on this as a strategy in identifying whether a website was phishing or not. They were also looking at and understanding URLs, so far more often. So it turns out the training was also quite effective at that. And they're also a lot more suspicious of websites that ask for too much information. So to answer one of the previous questions before, in this case, they actually did know that it was a, they were just asked to know that there were some scams here, and they just identify the scam, yes or no, and to rate their confidence in their judgment. There's a question in the back?
I mean, not a follow-up. I mean, that's immediately after they read the material. How about 3 months later?
Right, that's the subject of one of our ongoing studies right now. We're trying to figure out what's the right way of doing that. And in fact, that's the next thing I'll talk about in a second. Yeah, well, this is also sort of, it turns out there's two interesting issues here, but I'll get to that in a few more seconds. Okay, any other questions before we go on? Okay, so probably the main thing to take out of this is that people actually can learn from web-based training materials if only we could get them to read it, okay? Okay, but of course, people don't go to these phishing or these anti-phishing training websites because if they were aware of it, they'd probably, be sort of less likely to fall for these attacks in the first place. And it also turns out that a lot of companies send these security notices, the emails to their companies and customers. PayPal does this quite often, eBay does too. Well, I guess really the same company now. But these emails tend to be ignored. So one issue is that a lot of people say, when we talk to them about them, it's like they feel like there's too much to read. They also felt like they don't consider them relevant, or they also felt like, I already know this stuff. I've received this notice 5 times already. I already read through it. I'm not going to fall for it. And which, in fact, they actually do still fall for it. So what can we do about this? So another approach that we've been doing is something called embedded training. And here's the basic idea. Periodically, we, or some kind of third party, would periodically send lots of people phishing emails, but they're actually phishing emails from us. And if you happen to fall for the good guys, right? So this is white hat hacking, I guess. So, and if you happen to fall for one of our training emails, then you actually get an intervention that says, hey, you actually fell for this. Here are things that you should look for in the future, and here's how not to fall for it again. Okay. Now, I'm sure, of course, you can imagine there's lots of different phrasing for this that would be offensive. Hey, you're a bozo, don't do this again. That's probably not going to be very persuasive. So what we're trying to figure out here is what is the most effective way of trying to design these to make sure that people would actually understand this. And so this is actually just accepted to CHI 2007, and if you want to get one of these reports, just let me know, and I'll send the link to you later on. Okay, so here is one of the interventions that we actually created. So as you all know here from seeing too many PowerPoint talks, every talk has to have at least one slide with text too small that you can't see. So this is my slide here. So let me zoom in on some of the aspects here that are interesting. So this is one of our designs right now. We call this the diagram intervention. I personally call this the rationalistic design. This is probably something that any computer scientist would design off the bat because it's very rationalistic. Okay, so in the top left, it tells you, okay, protect yourself from phishing scams. This is something from Carnegie Mellon University, and you just fell for one of these scams, and this tries to explain to you how not to fall for them again. Okay, right below it actually gives you a diagram of the phishing email that you just fell for, and actually tries to point out some of the things that you should look for. There's a professional and legitimate looking design. It's trying to urge you to do something. It has an account status threat, and there's also one actionable item here, which is the mouse over. If you move your mouse over here, and if you look at the actual URL it's going to, they actually don't match. If you look over on the top right side, it tells you what is a phishing scam. So, yes, this question?
I forgot the grammar errors and punctuation mistakes.
So I'll talk about that in a second, but it turns out that the criminals are getting smarter because it turns out that most people don't fall for a lot of the ones that have errors like missing images and whatnot, but the criminals are getting much, much better. So I think that's getting much rarer right now. So that's why we didn't bother with that one. Yeah, it's sort of a pain. This is an interesting area because every design we come up with, we had to find, how would a criminal attack it, and the criminals aren't bozos. They're actually quite smart.
So are you admitting criminals into the PhD program now?
So the question is, are you admitting criminals into the PhD program? Well, we did admit you, Pejam, didn't we? Okay, and the last part, which is the bottom right side, is explain some simple, actionable things that you could do to protect yourself. So for example, never click on links within emails. You should initiate contact first by access the website by typing in the URL, call customer service, and never give out personal information. So one that was sort of controversial within our own group was call customer service. I mean, do we really want to flood them with all these calls? And our rationale is yes, because the banks aren't doing anything about it. They don't really have an incentive to do this. So this is actually one of the important statistics that we learned about this. So if you remember at the very beginning, I said that phishing costs about $1 to $2 billion every year. Okay, now, I don't know about you, I thought $1 to $2 billion was a lot of money. It turns out to the banking industry, it's peanuts, it's a rounding error, because the total cost of fraud, all fraud, is about $200 billion. So this is why right now they're not really doing much about this. So we're hoping by having people call the customer service and by our work right now to try to make sure that the derivative doesn't really grow much faster. So basically nip this in the bud before it becomes a problem. Yes?
List, and it's the same list that's on half a dozen other sites.
Yes, I know.
And from Google's perspective, it's a very interesting list. We send out lots of emails with links. We send out, some of it shared directly documented. Someone has posted their photos to this album and is willing to, and wants you to look at them. We don't have customer service phone numbers, or at least you can't find them very easily. So, there's an interesting conflict between these set of things to teach people, and because I've thought about, well, how would we invite people to look at your photos if we didn't send them a link or an email with the URL?
Right, so to paraphrase the question is, Google sends out a lot of emails requesting people to click on links anyways because, just got a new photo in your album, or I guess in Orchid and social networking, you would have a lot of these as well too. We actually updated this list to add one more, which is to be careful of websites that ask for too much personal information. And the top one, the don't click on links, was sort of a controversial one within our group too, because it's like, well, if you are an expert, you sort of know which links are good to click on and which ones aren't. But we're just trying to figure out, should we add nuance in this or not? And we figured it's probably easier not to add the nuance, because then we would also have to teach people what the nuance was, and we figured that would be too difficult. So I would agree that we haven't quite figured out the right set of heuristics to teach people yet, but I think this one is a pretty good set. And we still need to figure out what's the right way of trying to address the comments issue, or the new content issue that you were describing.
Issues on both sides. If this is what we're going to teach people, we have to teach companies. We have to figure out what companies are going to do.
Right.
If they assume that people are paying attention to these rules.
Right. Yeah. So you're Robin, right? So Robin was also saying that we need to educate companies as well as customers. That it turns out companies are also doing lots of bad practices too. For example, outsourcing their login sites to other places, or outsourcing their email to other places is not atypical to get, like email from like some company that might be in China, for example, that does their email services, which is really bad practice. It exacerbates this problem. But I think this is an ongoing conversation that really needs more work. Okay, so this was our first intervention. The second intervention, and what's interesting is that we almost did this half as a joke because we wanted to try something completely different in terms of the design space. So we said, well, what if we created a comic strip that sort of explains how the phishing attacks work? So the top part of this comic strip, basically describes right here, this is what the criminal is doing and how he's actually doing his work. And the bottom part is just saying what happens after they receive the email. Okay, so again, this is the intervention we actually use. We have an updated version of this right now. And it turns out that this intervention actually works far better than the rationalistic design that we have. So when we did the comparison of the study, we had 3 different conditions. First one was eBay and PayPal notices. We just used the standard ones that they sent out. We had a diagram that explains phishing, and then we had the comic strip that tells a story. 10 participants in each condition, 30 total. And roughly what happened is they went through 19 emails. There were 4 phishing attacks scattered throughout and 2 training emails as well. And it's basically the same story. You're still Pat Jones, you're still working for this company, and so on. And I won't show you the specific stats here. If you want, I have it as a backup slide. But unsurprisingly, the existing practice of security notices is completely ineffective. People, again, thought they already knew it, or I've already received tons of these, and they just didn't care. Diagram intervention, the rationalistic one, only works somewhat better. But sort of the surprising one is the comic strip intervention worked the best, statistically significant differences. And we're trying to figure out, well, why exactly is that? Is it because it's a comic strip? Is it because there's less text? Or, our current working hypothesis is it's because it's telling a story. So there's already some existing evidence in social psychology or just cognitive psychology that people remember stories really, really well. And so, I might be able to give you all this tabular data showing you which car to make and which car to buy, and Priuses get this kind of gas mileage and whatnot. And then you have a neighbor who says, hey, I just bought a Prius, it's really great. Which one are you going to weigh more? Most people actually weigh your neighbor. So it's sort of surprising. So our next steps on this is we've already iterated on the intervention designs. Oh, yes?
I don't know what the email system was, but if it was web-based or maybe even some other ones where you can control the client a little bit, if the user clicked this is spam, maybe you should reward them in some way. You see what I mean? And then they get positive feedback as well.
All right, so
with Gmail, you could do something.
Okay, so the comment is have people be active in terms of labeling spam and phishing attacks and being rewarded for that?
Labeling the intervention email.
Labeling the intervention.
Or the test email.
Themselves?
Yeah.
Oh,
like
so
for instance, okay, say I'm in your study and I get, 4 phishing one and 2, what did you call the intervention emails?
Yeah.
Okay, if I label those intervention emails and you know about it and you know I've done so, then you can reward me and say you did a good job. You're right, that is spam.
Oh, basically rewarding people for recognizing our training emails and possibly also other phishing emails too, which can also be used for collaborative filtering and other kinds of things too. I think that I'm actually talking to a company tomorrow, CloudMark, up in San Francisco, that is basically doing something that's like that right now. But the reward system is actually fairly trivial. It's just basically giving you a gold star. Hey, you're doing really well. And it works surprisingly well. Okay, we're trying to understand why the comic strip format worked better. We're also preparing for larger scale deployment to include a lot more people. We're also trying to evaluate the retention over time. So again, this is almost immediately. We're trying to figure out, well, after 1 week, after 2 weeks, 3 weeks. But we're also trying to figure out how often should you send these kinds of training emails, because you have to try to balance the education and annoyance level. And you definitely don't want to annoy the participants. We also want to try to deploy this outside lab conditions if possible. But this actually leads to our most interesting issue, which is the real-world deployment, and we're actually spoofing people's brands. So in fact, we're becoming criminals ourselves if we deploy this on the large scale. And in fact, I will say that eBay and Amazon have been quite effective in finding our fake websites because we have registered a few fake websites so that we could run these studies, and they were quite proactive in finding these. So kudos to them for that. But we actually need some corporate partners to let us spoof their brand and try to see how well this actually works in practice. Okay, and the last part of the human intervention side of things is we've actually been developing a game called Anti-Phishing Phil to teach people not to fall for phish. And so the embedded training focuses on email. This one focuses primarily on the web browser and recognizing URLs. So the main goals of this game is how do you parse URLs? Where should you look for URLs inside the web browser? And we're trying to also teach people use search engines too if you're not sure. Rather than clicking on the link, type in the information into a search engine. Like if you really want to get to eBay or Google, well, I guess if you're on Google, you wouldn't use that. But if you really want to get to eBay, then type it into a web browser. So it's going to be available on our website soon. Here's a zoomed in picture of what it looks like. But basically this is you, this is Phil, and no, actually that's Dad, I'm sorry, he gives you information, this is Phil. If you go over URLs, it tells you what the URL is, and you have to identify it as a phishing attack or as a real thing. If you're trying to eat all the different the worms on here, if you fall for phishing attack, then he actually gets roped up, or hooked up, and taken away, but it's okay because you have 3 lives. And this is your dad. You can always ask for help. One of the things we're emphasizing is that you can always ask for help. All right, so that, because in the real world, you can always use search engines. You can also call up your friends or call customer service as well, too. OK, so that's the human side of things. Any other questions before we go on to the computer side of things? OK, so again, I'm going to talk about the email anti-phishing. I won't be talking about the email anti-phishing filter we did. I will be talking about the automated test bed that we did to evaluate these anti-phishing toolbars and our own anti-phishing toolbar. So the question we're trying to answer for the first part is, how accurate are today's anti-phishing toolbars? OK, so there's roughly about 90 or so anti-phishing toolbars. If you go to download.com, you'll list about 90 or so of them. A lot of these are built into security software suites. Some of them are offered by ISPs. Some of them are free downloads. Some of them are built into the latest browsers. So for example, the latest version of Internet Explorer has one built in, and the latest version of Firefox has Google's built in as well. OK, so these two right here. The top one is what Internet Explorer looks like if it's blocking a website. It actually tells you this is a reported phishing website, and it tells you the URL. This bottom one is Firefox with the Google search, Google toolbar installed, and actually it gives you this large warning telling you not to fall for it. But again, we're interested more in how well do they actually work in terms of detecting phish. So this is sort of a separate problem too, because one issue here is, well, how well do people actually recognize that it's a phishing attack? That's sort of the human side of things. And we're looking more on the computational side of things right now, which is how effective are the actual algorithms that they're using. OK, so here's sort of a rough timeline of what we did. In April 2006, we did a manual evaluation of 5 toolbars. This required an army of undergraduates to get done. And let me tell you, it was not fun to do. We did this over a 2-week period, and it cost us a great deal in terms of pizza. Summer 2006, we had a very talented PhD student that was visiting us from University of Pittsburgh. He created a semi-automated test bed. I'll describe in a second more of how this actually works. In September 2006, we did an automated evaluation of 5 toolbars. It took us about 1 or 2 days, and we used the APWG feed. APWG stands for Anti-Phishing Working Group. It's a consortium of companies, and they actually have a phishing feed that members of this can actually acquire. And in November 2006, we did an automated evaluation of 10 different toolbars, and we used a different website. This time we used phishtank.com as a source of phishing URLs. So phishtank.com is basically trying to do the same thing as APWG is doing, in terms of anybody on the internet can submit what they think is a phishing URL or a phishing email, and then other people can also rate how effective those URLs are, whether it's actually phish or not. We evaluated 100 phishing websites and 510 legitimate sites in just 2 days. Okay, so this is much better in terms of performance and in terms of evaluation time. So this work is about to be published in NDSS, the security conference. And actually, I do have copies of this paper here with me right now. So if you want paper copies, I can get them to you after this talk. OK, so again, the reason for creating an automated test bed is that the main evaluation was very tedious and slow. So the idea was, can we just create a test bed, and we just give it a set of URLs, and we already know beforehand whether they're phish or not, and then the test bed would just run off, evaluate all the different toolbars, and just come up with statistics at the end. So one question is, how do we automate this for different toolbars? Because a lot of the APIs are not open for these toolbars. So and also they're also running on different web browsers. So what we decided to do was take an image-based approach, which is we know what the toolbars should look like if it's a phishing attack or not, because they have some kind of signal there. They either turn red, or they put up a block, or something like that. So we just use a very simple image-based approach, which is, well, if we know this web browser shows green, yellow, or red, and we know where it should be in the web browser, we just take a screenshot of the web browser, clip out the right part of it, and compare it to our a priori image. So it's a very simple approach, and it actually works quite well for us. If you're interested in this test bed, we just put it together, and it's available for download. Actually, I don't know if it has a URL yet, but you can get a copy of it if you want. So roughly speaking, here's the architecture. We take a phishing feed, again, either from APWG or from phishtank.com. It gets sent to a task manager. The role of a task manager is just to delegate all the URLs to a specific web browser with a specific toolbar inside of it, and also aggregates all the statistics. It sends the URLs to various workers. Each worker is responsible for a single web browser and a single kind of toolbar. It downloads the web page. Right now we're using the Tor anonymizer because we also don't want all these phishing sites to know that we're doing this or whenever we're scanning for them. It comes back, it says whether it's a scam or not, and then just sends the data back up to the task manager and aggregates all the statistics. Okay, so something that's very interesting too is that in terms of how do we get these URLs to find the phishing attacks. So we need a source that has lots of fresh phishing URLs. We can't use the toolbar blacklist themselves because, or if we do that, then we can't evaluate the same toolbar because otherwise we'll get 100%. Sites also get taken down within a few days. The average time a phishing website is up is about 4.5 days, it turns out. We also want you to observe how fast blacklists get updated. Obviously, the faster it's get updated, the better it is. And we also experimented with several sources. So to give you more information, the APWG is very high volume. It gets lots of raw emails. People just forward emails that they think are phishing attacks. There's lots of duplicates, and there's also some legitimate URLs included inside of them. So it's also some false positives. For phishtank.com, it's lower volume, but it's far easier to extract the phishing URLs. So it turns out they just give you an API for getting these. There's also other fish archives that we've experimented with. We tried accumulating ones ourselves, but they're typically low volume or not very fresh kinds of emails. So it turns out that the choice of your feed that you're using actually impacts your results. So the results I'm about to show you, they're roughly order of magnitude. They might be plus or minus 10% depending on the weather or how many emails you get and so on. So, but I mean, roughly speaking, they're roughly correct. Okay. So we tested 10 different toolbars. I won't read them all off over here. Most of these use blacklists and simple heuristics. So SpoofGuard, this is one that's developed by Stanford University. This is the only one that relies solely on heuristics. Everything else, as far as we can tell, relies partly on blacklists and maybe a few simple heuristics. Okay. And now on to our results. Oh, next one. Oh, how do we actually get our URLs? So we used 100 manually confirmed fresh fish from phishtank.com. So phishtank actually has a staging area for URLs. So whenever a person actually submits the URL, it goes into one area. Then somebody else or several people have to validate that it actually is a phish. And then that goes onto their main feed. So we use the invalidated feed, or not invalidated, unvalidated feed currently to do that. And the reason for that is because we believe that some of the toolbars already use the validated feed, so we want to try to make sure that we didn't have any kind of crosstalk there. In fact, I think the Google toolbar uses the PhishTank, I believe. We also had 60 legitimate sites that were linked to by phishing messages, so we kept those and tried to see how bad some of the toolbars were in misidentifying legitimate websites as illegitimate. So those are false positives. And we also had 510 legitimate sites that were tested by another company called 3Sharp in a September 2006 report. Okay, so here's a very large graph that shows the results. Okay, so one thing that you'll notice immediately is that McAfee's protection is not very good, and with a total amount of 0%. But since I'm being recorded, I want to add an important caveat, which is that this is the marketing problem. It's not McAfee's problem. So the marketing website says that it protects you from these kinds of online scams. But when we talked to them themselves, they said that, well, that's really what the marketer said, that we didn't really claim that. And so we believe that there's also another version of this that actually does do this correctly, and they have given us access to do that. So in the next version of this, we will show much better results for McAfee, I'm sure. Another interesting one is the one at the very top, that's SpoofGuard. So you notice it's roughly about 90% pretty much all throughout, so that's very good results. But you also notice that there's a little caveat there in one of those little post-it notes at the very top, 38% false positives. Okay, so that's basically saying, you really go to a legitimate website and it says, hey, this is a scam. All right, so that's not really that great. It's pretty good results in terms of the terms of the true negatives of finding phishing websites, but not so great at false positives. I guess one that probably would be of interest here is Internet Explorer. So you notice that Internet Explorer is near the 70% level right now, so that's actually quite good. That's their latest version of Internet Explorer. And then there's the Google toolbar, which does slightly better over time. You notice that it increases after about 12 and 24 hours. So that's pretty good results. So overall, if we just summarize the results, there's only one toolbar with greater than 90% accuracy and unfortunately has high false positive rate. Several toolbars catch about the 70 to 85% level, so that's pretty good with very few false positives. One thing that's important to note is after about 15 minutes of training, this is roughly about how people do as well in the training that I described earlier. So maybe if we do a combination of the two, that might be pretty good. There's few improvements in catch rates seen over 24 hours. So this suggests that most toolbars are not taking advantage of available phish feeds to quickly update their blacklist. Okay? So if you go back again, you notice that there's very few upturns after time. Like for example, the Netscape one does, the Google one does, and Netcraft does as well. So there's not a lot of these feeds that are updated. Yes?
Now the fact that they are going up between 2 and 24 hours for Google and 12 and 24 hours for Netscape, does that imply that they're using that other list that has been super confirmed, or?
Yes, that's what we believe. But the problem is that a lot of these are sort of like black boxes, so this is more of our conjecture as to how they work. So we're trying to reverse engineer them. Oh, so the question is the uptake really because of using the available phishing feeds? And we believe so. Let's see what else. So it seems like a combination of heuristics and having a frequently updated blacklist is probably the most promising approach. Yes, there's a question in the back.
This is slightly unrelated. Do you know how long after someone receives an email do they fall for a phish? I mean, does this increase actually help?
We're not sure. We don't really. I can't really say one way or another. We don't have empirical data on that. I could probably take a wild guess if you want me to.
If it's 3 hours, then it doesn't help that your phish feed gets better.
Right.
That's 24.
I mean, generally speaking, the best approach is just do as well as you can, as fast as you can. I mean, that's probably the most obvious answer, but I really don't know about how often people check their emails and whatnot. Yes, another question?
Does the false positive actually matter that much?
Does do false positives actually matter is the question. So here's sort of our thinking on this. The true positives are good because that means you correctly identify a legitimate site as legitimate. False positives can be annoying, and if you were at that site, it could be detrimental. False negatives, where it's actually a phishing website and you don't identify as a phishing website, are the absolute worst ones. So it sort of depends on your perspective. If you are the user and you get a false positive, it's probably not a big deal. But if you are that company, maybe they might sue you. So that could be pretty bad. Yes, there's a question?
Okay, so some things that one of our sites is actually marked as a phishing site, which means that people just ignore all phishing sites. All sites are marked as phishing sites. So that means that you can deliver if you have 28% of false positives, that it says browser or you want to consider any more than phishing drugs.
Oh, okay. So if I understand correctly, you're saying that if you get too many false positives, then people might start ignoring the errors? Right. Yeah. Okay, that's probably that's a good point too, right? Which is the human side of things. If you get that many high false positives, you might start ignoring everything that your browser is telling you. Right. Okay. Any other questions before we go on? Yes, another one.
Using whitelist instead of blacklist.
Right, so the Stanford Spoof Guard actually does use a whitelist. The problem is that I think that there's far more legitimate sites that are out there that you could easily encapsulate inside of a whitelist. And plus, the other problem too, which is quite an interesting one, is that the way that some of the scammers are getting past some of these blacklists is that they attack legitimate websites and then host their fake website on top of it. So we've seen stuff like Rolling Stones fan club sites that have been broken into, which is a legitimate site, but then they have one small part that is a new URL that actually contains a scam. There's actually a famous incident in Hong Kong a few months ago where one bank's website was broken into and it hosted, and it probably wasn't them, but it hosted an attack on another bank in Hong Kong too. So you can imagine that being a serious problem. So there's sort of a balance that needs to be taken with whitelist too, because this sort of becomes a vulnerability, and you have to make sure that if you put all your eggs in one basket, you have to really watch that basket closely. Okay, great question. Let me go on quickly. Oh, okay. So we are planning to periodically repeat the study every quarter just to see how things are updated. And again, you should only consider this as a rough ordering. So depending on which phishing feed we're using, things might be up or down 5, 10%. We're not quite sure exactly what. But again, I think that roughly speaking, these are in the right order of magnitude. Okay, so the last thing I want to talk about is our anti-phishing toolbar that we've been using. And to do this, it's probably good to take a few steps back into, I guess in recent history. This is some work that was developed at UC Berkeley a few years ago by Tom Phelps and Robert Walensky. Tom Phelps is a PhD student there. Robert Walensky is still a professor there. And what they were trying to do was develop a way of having robust hyperlinks that would survive 404 not found problems. Okay, so the basic idea is, you click on a link and then it takes you to page not found. That's sort of annoying. So they were trying to see, can we solve this problem once and for all? And their idea was a pretty simple idea, but it seemed to work pretty well, which was, what if you added a small lexical signature to URLs, and if the actual URL fails, then you feed that lexical signature into a search engine, and then that search engine would probably lead you back to the page that you were looking for, or a highly related page. So the lexical signature might look something like this. So if your actual URL you want to get to was abc.com/page.html, and then the question mark afterward would probably be ignored by most web servers, and then you could actually include your lexical signature there. If this URL returned a 404, then maybe your browser could automatically feed all of those words into a search engine, and then hopefully you would be able to find your actual page. So this all hinges on the question of how do you actually generate the signature that is effective. And through some of their informal experiments and evaluations, they found that an algorithm called TF-IDF, term frequency, inverse document frequency, is actually quite effective for this. So TF-IDF is probably the most well-known information retrieval algorithm. And let me give you an intuition of how it works. You want to find TF-IDF, the TF part stands for term frequency. You want to find words that are very common on a web page. And the IDF is inverse document frequency. You want to make sure those words are not common on other web pages. So for example, if you went to eBay's web pages, the word eBay and auction are probably quite common on eBay's web pages, but very rare on any other random web page out there. Okay? So their idea was, if you apply TF-IDF to a web page and you find the words with the highest scores, then how many words would you actually need for this algorithm to work? And they found through some informal evaluations that 5 words is actually effective for finding most of the web pages that you want. Okay, so this is sort of a surprising finding. You only need 5 words, and you can usually get back to the web page you're looking for. So we were thinking about this more, and we're thinking, well, could we actually adapt the same algorithm for anti-phishing? And so part of the rationale we think this works well is because scammers often directly copy web pages. So you notice here the fake eBay web page and the real eBay web page, they're pretty much the same in terms of the actual content. The only thing that's different is what URL that this thing is sending the data to. The other thing too, which is sort of the preview of the how we use the Google search engine, the fake one should actually have a lower page rank too, because there's not a lot of other web pages that are linking to this. Okay, so in theory, if you put the same words into it, if you extract the words from this, you should get to this page and not the fake one, because no one's really linking to this, and it should have a relatively young age, again, because most phishing websites are up for only 4.5 days. So here's the rough algorithm how it works. Given a current web page, calculate the TF-IDF for each word on the page, take the 5 terms with the highest weights, feed those terms into a search engine, which currently we are using Google, and then if the domain name of the web page you're currently on is in the top N search results, then we consider it legitimate. And so we experimented with N as well too. We discovered that after 30, it's pretty much the same results. So if it's not in the top 30 results, then it's pretty much the same. Okay, so here's an example of what the eBay one would look like. So the TF-IDF words for the eBay web pages I just shown were eBay, user, sign, help, and forgot. And you might notice that, let's see, which one is it? It's this one right here. So this is 1, 2, 3, 4, 5. The 5th result is actually the correct web page. So this is actually a pretty good result. You also notice that a lot of the other ones also have like ebay.com, paypal.com inside of it as well too. So again, just by checking the domain names, this turns out that this would have detected the fake one and the legitimate one. It would have identified those correctly. Okay, so our first evaluation for this, we had 100 phishing URLs from fishtank.com and 100 legitimate URLs from 3Sharp's study. And so we tried a few variations of this TF-IDF algorithm. The first one, this one right here, it's called basic TF-IDF. It's just, just using the algorithm I described. The true negatives in terms of identifying phishing websites is 94%, which is pretty good. Unfortunately, the false positive rate is about 30%, so that's not too good. So we also added a few heuristics, very simple heuristics, to see if we could fix this. So the next one is basic TF-IDF plus domain. And so basically this means, well, add in the domain name of the website you're currently on as one of the terms into Google. So basically instead of having 5 words, now it's 6 words. And so for the eBay example, it would also just add in the word eBay again. So basically it would be there twice. So unfortunately, the true negative decreases to 67%, so that means it's not as effective for identifying phishing websites. But you'll notice that the false positive rate also decreases down to 10%. So that's one of the trade-offs here. We tried another approach called TF-IDF plus ZMP. So ZMP means zero results means phishing. So if you don't get any results, we identify that as phishing. So just trying it by itself, this is just as a proof of concept. We don't really intend for this to be the actual algorithm used. But just as proof of concept, you'll notice that it's pretty much the same as the true negative as the original algorithm, and it really doesn't have any effect for false positive. However, the interesting thing happens when you combine those two results together, those two heuristics. So when you combine the TF-IDF plus including the domain name, plus including the zero results means phishing, you'll notice we get our best results, which is 97% in terms of identifying phishing websites, and only 10% in terms of false positives. So we think that's pretty good results. Yes, please?
Sorry, can you describe again what true negative means?
So in this case, the true negative, this is something that we also get sometimes confused as well, because which ones are true positives and negatives. True negative means it identified a phishing website correctly.
Wouldn't that be true positive?
Trying to think if we got that one right. So basically the question is the website legitimate? And so if it's legitimate, we called it a positive, and it's negative, we said if it was, right. Yeah, so I actually have a diagram showing this at the end too. And I think we need to come up with better terms because again, our group also gets confused with the terms as well sometimes. But the main thing is that this is correctly identifying fake websites. This one is incorrectly identifying legitimate websites. Okay, so some discussion, pretty good results, but the false positives, it's 10%, so it's okay, but not great. So what we did was we added several more heuristics to reduce the false positives. Many of these heuristics have been used by other toolbars and other algorithms as well too, so we won't claim that we invented these. But some of these include the age of the domain, so if it's less than 12 months old. If it has known images, so for example, if it has like Google's logo or if it has eBay's logo or so on. Suspicious URLs, ones that have the @ or a dash. Suspicious links, so any links that also have the same characters. If it has IP address in the URL. My favorite one is number of dots in the URL. It turns out that if you have more than 5 dots in the URL, it's probably a phishing website. If the page contains a text entry field. So the rationale behind this one is that if there's no way for the person to communicate, type in their information, then it's probably not going to be a phishing website. So this means that we don't consider this one doesn't detect the email ones where they expect you to apply for a job, for example, and send in your resume. And then finally, we also include the TF-IDF. So this uses a very simple forward linear model to weight these. So just the intuition here is we try to figure out which ones are the most useful in terms of identifying phishing websites, and then those would have a greater weight than the other ones. So the ones that turned out to have the greatest weight turned out to be these two, and the other ones are sort of a small order of magnitude, just small effect there. So what we did in the second evaluation was we compared this to SpoofGuard and Netcraft. So again, SpoofGuard is one developed by Stanford, uses all heuristics, and had very high accuracy in terms of identifying fake websites, but had a pretty high false positive too. We also compared this to Netcraft, the latest version, 1.7, which we believe uses some heuristics, but we're not sure because again, it's a black box, and also has an extensive blacklist too. In some of our earlier experiments, Netcraft was the best one, and the one I showed you, it was probably number 3 or so. So this time we did a slightly different evaluation. We took 100 phishing URLs from fishtank.com again, and this time we did, for the legitimate URLs, we took sites that were often attacked, so we took Citibank and PayPal and some other ones. We also took the top pages from Alexa, so these are the most popular websites, and we also took some random web pages from random.yahoo.com. Just to see how well this would actually work. So roughly about 30 in each of these. So the results, so again, this is how well the toolbar could actually identify a fake website correctly. So final TF-IDF, this is the one that I described to you earlier. This is without any of the heuristics. So it did about 97% in this case in identifying fake websites, so that's really good. And had about a 6% false positive rate in this case. So the difference between the 6 and the 10% I think is probably within statistical noise, but we haven't really done any tests on this, sort of more of my conjecture. Here is our algorithm with the heuristics built in. So you notice that our accuracy in detecting fake websites has decreased from 97 to 89%, but you also notice that the false positive has decreased down to 1%. So we think that's pretty good. You'll see that SpoofGuard is 91% and has a 48% in false positive rate in this case. And Netcraft has 97% accuracy and 0% false positive. And we believe that this is because they actually do have a person or several people there manually verifying every single one that goes through them. Okay. So we think these are pretty good results because here we're using an automated algorithm that does roughly as well as Netcraft, except has some of the false positives there. Yes? So the false negative is basically take 100% and subtract from here. So in this case, we had 3% false negative in this basic algorithm, and this one had 11%. Okay, and I'll actually discuss what are the actual, right. So the false positive, or the false negatives, actually I have the wrong term up there. That should say the false negatives turned out to be primarily this JavaScript attack that is sort of recent among lots of these different phishing websites. So what the JavaScript attack is you go to a website and then the JavaScript will load in the other website and then change something in the DOM so it'll actually redirect the information to them. So we're actually adding a special heuristic just to detect this specific JavaScript attack. There's also some limitations to our approach. It doesn't work very well for non-English websites. The reason for this is because if you have an Asian language website, for example, it's really hard to get document frequency or word frequency across the entire corpus or across the entire web. So this probably requires some specific approaches for Asian languages. There's some system performance issues because here we're querying Google every single time to actually get the results of whether it's legitimate or not. And we've also been considering how would criminals actually attack this. So the most obvious one is what they're already doing with spam, which is to use all images rather than words. So this would probably require some more OCR if you want to do that, which would further impact system performance, unfortunately. The good news is criminals aren't doing this yet. The bad news is, again, the criminals are actually quite smart, and so they probably will be doing this soon if this is deployed. Is the question here?
But if the criminal uses images and legitimate companies does not use images, then there's a big difference there.
It's possible. Again, the criminals are probably smarter than we expect. So I mean, it's not clear to me what's going to happen afterwards. But if you look at what's going on with spam right now, I mean, they try images, they put these random dots inside of it just to foil all the filters. I suspect that they will be clever and try to figure out ways of doing this. So probably the best thing to do is, work on this early and try to figure out how criminals would defeat it and try to get a step ahead of them right now. Invisible text is another issue, but I think this is easily detectable. And circumventing TF-IDF and PageRank. So we're actually not sure if it's actually easy to do this or not. We have our suspicions that TF-IDF is fairly robust. It's actually quite hard to subvert this. And my suspicion is that, over here at Google, that PageRank is being attacked all the time by search engine optimization companies. My suspicion is that that's also fairly hard to circumvent as well, too, or to subvert. But again, we don't have any statistics or data on how well or how hard or easy it is to do this. Okay, so the quick summary. This is the last slide. Again, we are a large multidisciplinary team at Carnegie Mellon looking at trust decisions, currently focusing on anti-phishing. I described some of the human side of the things that we're doing with respect to interviews to understand how do people make decisions, what cues do people look for, and so on. I described some of the embedded training that we've been doing to try to train people surreptitiously in the context of the regular email use. And I've also described an anti-phishing game that we've done. On the computer side of things, I described an automated test bed for anti-phishing toolbars and our current anti-phishing toolbar that, again, uses the Google search engine to find a lot of these scams. Okay, so that's it from me. Are there any other questions from you guys? Okay, well, thank you very much.